Measurement of resources. Resource analysis provides the objectively measurable material basis for assessing the situation and decision-making behavior of farmers. Subjective reasons for decisions, such as humanistic, ethical, and religious criteria or feelings such as social satisfaction, freedom, or happiness, are reflected in existing resource use, in accordance with the hypothesis of horizontal analysis discussed in the previous video clip. The measurement of resources provides information about the profitability, in other words, the economic efficiency, of their use in the various areas. In addition, there is their availability over time and the costs incurred for their maintenance. This results in comparison and control coefficients from the relationships between resource use and the results achieved, in other words their productivity and the production coefficients, which describe the relationship between the overall availability of a resource compared to the availability of other resources. Creating a concept for measuring these parameters requires considerations and decisions in three areas. The first area is the breakdown of each resource into quality classes according to differences in value and usability. The second area concerns the selection of measurement scales for the quantity of the respective resources. The third area is the selection of appropriate values for each resource. Concepts for the classification of resources according to their properties and quality can vary regionally. For example, in Germany and Europe, there are DIN and EN standards for distinguishing between suitable water for irrigation and household consumption, but these do not apply in other parts of the world. The situation is similar with the assessment of soil quality. For Europe, there are specifications from the European Soil Data Center, or ESDAC for short, but these are supplemented or modified even within Europe by national mapping. Internationally, there is sporadic information on soil quality in the World Reference Base for Soil Fertility. However, other countries also generally use their national soil classifications. Water and soil serve here only as examples to illustrate the necessary considerations when developing a measurement concept. The scales for measuring quantities are also not always clearly defined. This particularly applies to resources whose scale is not scientifically determined. For example, measuring land in hectares or water in cubic meters is unproblematic in most cases. However, for resources whose units of measurement are based on agreements rather than scientific constants, definitions must be established that are appropriate to the specific case. This applies, for example, to a person's work capacity, which is often measured as 40 hours per week. But this rarely corresponds to reality, especially in agriculture. Consequently, the creation of the measurement concept also requires decisions regarding the units of measurement of quantity that are tailored to the specific case. When evaluating resources, the need to select the relevant value arises from the fact that each resource can have multiple values simultaneously. Analyses by external experts align the selection of the relevant value with the goal of profit maximization. However, internal analyses by farming families do not necessarily have to follow this economic principle. The key characteristics of resource assessment can be summarized in three aspects. First, the focus is on measuring the material basis with which decision-makers of farming systems pursue their goals. Second, measurement for this purpose aims to determine economic indicators that, in addition to recording the current standard of living, allow assessments of the effectiveness and efficiency of resource use in the various areas of farming systems. Third, a situation-specific measurement concept is required for recording and assessing resources. The basis of measurement concepts for analyses by external experts are the rules of rational, economic assessment. Internal analyses by decision-makers of the affected farming system allow for greater flexibility by adapting assessments to individual preferences.